Hi, welcome to my problem set number 3. So here's the breakdown. Students appear to have rationalized their illicit behavior based on their perceptions of how their teachers view cheating. Poor teachers are thought not to care or whether their students cheat, so cheating is okay in their classes. Good teachers, on the other hand, do care and are alert to cheating, so students tend not to cheat in their classes. The following are hypothetical data similar to actual research results on this topic. The scores represent judgments on the acceptability of cheating for the students in each sample. So for A, I have say no to F max test. A says, explain why we cannot do an F-max test to evaluate the homogeneity of variance for the samples in this study. My answer is because we cannot do an F-max test because in order to complete such, all data must have been sampled on a random basis. Part B, explain how the values for t and sum of x squared are calculated for a given condition. Why do you think that we use the sum t instead of the notation sum of x? So as you can see, I have t versus sum of x squared. My thoughts are the value of t is calculated by the number of individuals multiplied by the mean for each individual group. Therefore, for sum of x, you square each score, then add them up. That is how you calculate each one for a given condition. But we use t instead of the notation sum of squares because we're trying to find the total scores for the groups separately, not for the entire equation. Now we're on to the fun stuff, all the adding and subtracting, multiplying. Hopefully you enjoy seeing my balloons because that's considered as a party. So with one way ANOVA, that is what we're doing for this problem. I broke it down to show exactly what we'll be starting with and what we will be ending with. For number 1, we're going to find the degrees of freedom for the between and within treatments. Number 2, we're going to find the sum of squares for within and the mean of squares for within. And number 3, sums of squares for between, mean of squares for between. And finally, number 4, find our F ratio. DF for between equals K, which is the amount that's going to be treated minus 1. So there are 3 treatments: poor teacher, average teacher, good teacher. Minus 1, so that equals 2 for degrees of freedom for between. For degrees of freedom for within, you have N, the total of scores for the sample, minus K, the amount of treatments in the sample. Therefore, we have 72, we have 24 participants, and we have 3 groups. 24 times 3 is 72, minus 3 from the 3 treatments: the poor teacher, the average teacher, and the good teacher, and that equals 21. The numerator is the between DF, so that's 2, and the denominator is within DF, so that's 21. On your F table chart, you will go over at the top for 2, go down to 21, and you will see your critical value 3.47. Part 2. Sum of squares within is sum of squares, the sum for the sum of square levels. So since we don't have to calculate the sum of squares, since we already have them, I'm showing you how you add them. We have 10 for the poor teacher, 28 for the average teacher, and 34 for the good teacher, equaling up to 72. Now, this is something different. Since we have our SS within, which is 72, we need to find our next step, mean of squares for within. And that's sum of squares over DF. Now you have to just go back and you will see that we did 21 for our degrees of freedom within. Therefore, 72, which is our sum of squares, over 21, our DF, equals 3.42, our mean squares within. And we're going to need this later to to complete our F ratio. I have SS between, the sum of t squared over n minus the grand total squared over the big N. Poor is 36 squared over 6, so that's the amount of individuals in that group, plus the average total, 32 squared over 8 individuals, plus good, 22 squared over 10 individuals. And you see that these are my calculations at the bottom. For the sake of time, I'm just going to move on. Adding everything up in the end, you get 384 for the total of just the total square over n. Now for the grand total square over the big N, you get 88 squared over 72 from previously. This is why you need everything from before. You hear your calculations, and the sum of squares between is 107.56. Just as before, we have mean of squares between SS over DF. Therefore, you get 53.78. To find F, we get mean of square between over mean of square within. 53.78 divided by 3.42 equals 15.73 for the F calculated. We cannot do for part D 2K's HSD because we have different amounts of participants. In the sample, in order to do 2K's HSD test, you need to have a balance of participants. As you can see, we have 6, 8, and 10. The driving force for this group is the poor teacher. So you see I have the car, the poor teacher is driving it, because the poor teacher is driving the group because the average number of such is the highest among the students' perception of the teachers. With effect size, you just have SS between over SS total, 107.56 over 179.56, and that will equal 59%, and that's a medium effect. And as you can see, this is my APA style. F, degrees of freedom in the middle, equals 15.73. P is greater than the alpha level, and effect size is 59%. Thank you for your time. Sorry for going over. Hope you enjoy the video.